Hello everyone. So, welcome back to another session on numbers. Hope you're all doing well. Now, let us start with our next thing. Do you remember what we had done in the previous session? Hope you have watched the recording before coming. Alright, so let us move ahead. Do you remember this thing? This big elliptical. Okay, let us not use the word because you will be studying it in the higher grade maths, right? Okay, so in this figure, you remember what we had done? Well, I hope so because this was also your worksheet. And what else was there on numbers that we covered? Do you remember this? Even numbers, odd numbers. The numbers which can be divided by 2 are even numbers, and those which cannot be divided with 2 are odd numbers. What were primes? The numbers which can be divided either with 1 or the number itself are prime numbers, and the numbers which are not divided with just 1 and the number itself but other numbers as well were the composite numbers, right? All right, and after this, do you remember this one? 5 rational numbers. Finding the rational numbers in between the rational numbers. Not just with tens, but even with hundreds as well. If you have not done this, make sure you're going back to the recording, all right? And then this thing where we needed this beautiful table, this beautiful figure, right? Now, let me ask you one thing if you have done this. Do you think all the rational numbers are real numbers? Well, the answer to this is yes. Because as we can see, the real numbers are containing all the types of numbers. So, we can say all the type of numbers are also real numbers, right? Okay. Now after this, you know how to represent 1, 2, 3, 4 and all the numbers on the number line. Even you know how to represent the rational numbers on the number line like 2 over 3, 5 over 7 and so on. But what about root 2, root 5, root 11? Do you know how to represent the irrational numbers on the number line? If you don't, then let me just show you how to draw root 2 on the number line. Magically appeared, right? Okay, so see here we have the number line, and on this number line we have written all the numbers. Can you see this 0 to 1 is 1 unit, right? Now see, we have this 0 to 1 as a 1 unit, and now what are we going to do is we are going to do construction. So what is it construction? We are going to place this compass at the point 1 and make a perpendicular on it. So we know how to make a perpendicular. We have done that in the previous classes as well. So we just made a semicircle, then place the pin of the compass on one side, make an arc on this semicircle, then place the pin of the compass on the arc that we just made where the semicircle and arc are cutting, right? And then make another arc. So we made 2 arcs. Now we want their middle point, right? We make another arc on the same point by keeping the pin, and then another arc above, right? Yes, like so. Now we have made a cross. Now we are going to use our ruler and pencil to make this line. See, going from 1 and the cross. Now this should be 1 unit also. So let us measure by using our compass and pencil 0 to 1 distance. Okay, so 0 to 1 is this much. Now, after fixing it, let us mark an arc on this pink line. Place this pin of the compass on one point, number 1, and then mark an arc on this pink line. Now, this is our 1 unit, right? So we have this 1 unit now. What else? Last step. Just name these points. 0 is A, then B is 1, B to C is 1 unit, right? Because we just made it so. Now we just need to join A and C. So when we join A and C by using a ruler and pencil, this AC is nothing but root 2. So this is how we can make the length root 2 by using compass and pencil, right? Our ruler, geometry box. Now, root 3. How do we plot root 3 on the number line? Or find out the length of root 3 on the number line by using a geometry box. So let us see that. Now for this, we are going to do the same thing. But on the line root 2, we just extend it. Can you see the gray line? We just extended this orange line, and on this point C, we make the same semicircle 90 degree. So put your compass on the point C and make a semicircle over here, and we are going to make perpendicular in the same way. Semicircle. After making the semicircle, place the pin of the compass on one side of the semicircle. Make a cut on the semicircle, right? Yes. So after making this cut on the semicircle, we place our pin on the cut, right? And then we make another cut here. Here we make another cut. Now after making another cut, again we are going to cross. Yes, like this, and same, place the pin over there. Yes, and make a cross. Now from this cross, the cross that we have made and the point, yes, C, and this cross, we are going to make a line with a ruler and pencil, right? So let us make a line with a ruler and pencil which is going through the point C and this cross, like this. So this is our perpendicular that we have made. But the thing is, this should also be 1. So this should be 1. So we again use a compass and pencil and measure the distance 0 to 1, which is 1 unit. So we lock it and place it over C. Make an arc on the blue line, right, which will be of 1 unit. This green C point to the green arc is nothing but 1 unit. Yes. So we have this 1, 1, 1 and 1, right? Now this is root 2, and let us give this arc as the point D. Now just join A to D. So when we are joining A to D, this is nothing but, can you guess what it is? Yes, root 3. If we want to make root 4 on the number line, what can we do? So same, we extend this root 3 line further, and again by extending it, we make a perpendicular here like this, and then again we make a line of unit 1 and then join A point with the arc. We will get root 4. So this is how we can draw root 4 and so on. Root 5, root 6 and so on we can make, right? Now after doing this, we have root 2, root 3 and so, but how to plot it on the number line? We have drawn the length, but how to plot it on number line? So we will need the help of our compass. Measure root 2, how much it is, with our compass and pencil. So when we have measured it, what are we going to do? We are going to place our compass pin on 0, and then we are going to move this pencil towards the number line like this, right? Here we will get root 2. So we make an arc from here and towards our number line of root 2. Here we got this. So this red line where it is cutting is the length from 0 to this red mark. It is nothing but root 2. So we know 0 to this red point is nothing but root 2, right? Now what about root 3? Same. Take our compass, pencil, measure A to D distance. Then log the distance, finalize it. Again, we are going to make an arc on the number line like this. Wherever it is cutting, that will be our root 3 distance. So again, we make an arc, this black arc where it is cutting. So here it is cutting, and up till from 0 to where it is cutting the number line, the black arc, up till here, this orange line, this length is nothing but root 3. So this is how we can draw the length of root 3. We can plot or represent root 3 or locate root 3 on the number line. Similarly, we can locate other points as well. on the number line, which are irrational, right? So now we know how to draw root 2 on the number line, right? Root 3 on the number line, and we drew it very well, and also know how to draw further root 4 and what is the process for further roots. But what is the proof that the root 2 that we have drawn is true and this AC is always root 2? Well, let us check this out. To know if it is really representing root 2, what we have to do is, let us check our construction, right? So first we drew a line. The line was of 1 unit, right, which is AB. Then on this B point, which was 1, we drew another line, right? Another line which was again of 1 unit, right? Another line of 1 unit. After that, now this 1 unit green line that we had drawn, what was it? Well, it was a perpendicular, right? It was a perpendicular line. So whenever there is a perpendicular line, this line, then we had joined this and this point, right? We call this as C. Now see, whenever there is a perpendicular line and this is forming a triangle which is having 90 degree in it, what kind of triangle is it? Right angle triangle, right? And on right angle triangle, what is that theorem that can be implemented? You know what is that line which is opposite to 90 degree, called as hypotenuse, right? Now do you remember? Yes, Pythagoras theorem. Pythagoras theorem we can implement here. Now Pythagoras theorem says hypotenuse square is equals to base square plus perpendicular square. But hypotenuse we don't know. So hypotenuse we know is AC. AC square equals to B. Base is AB. AB square plus perpendicular is CB, right? This square. Now AC square, if we don't know, equal to AB square, which is 1 square, plus CB square, which is again 1 square. And what is 1 square plus 1 square? Yes, it's 1 square plus 1 square is 1 plus 1. So AC square is equals to 1 plus 1. That means AC square is equals to 2. So how do we find AC? There is a square. So we will have to remove this square, right? For that, we just have to take square root on both sides. We get root 2, right? AC equals to root 2. So this is why it is true that this AC that we are forming here will always be root 2. Now this is proved. Okay. But what about the triangle ACD? Can you see this triangle which is ACD? What about this? How can we prove that? Now let us look at this as well. ACD, right? So we have this triangle ACD. What is the base for AC? Let us draw a line. See, the base for AC is root 2. And we made a perpendicular line over it, which is CD. So this is AC and this is CD. CD, which is nothing but 1, right? So this is 1. And then what did we do? We joined this A and D and we said this is root 3. But how is that possible? Again, because we drew a 90 degree line over here, so which theorem can be implemented? Right, Pythagoras theorem, which is hypotenuse square. Hypotenuse is what? The line which is opposite to 90 degrees hypotenuse. Hypotenuse square is equals to perpendicular square. Interesting geometry, right? Square. Perpendicular square plus base square. Hypotenuse is this one, which is AD square equals to perpendicular. Perpendicular is CD square. What is happening? Magic thing is happening, right? Maths, circle, squares. CD square. CD square plus b square. Okay, let me just erase it so that you don't have any problem in understanding this, right? So perpendicular is c d square, right? Plus base is this a c square, right? Now we just put in the values over here. AD square, let us suppose we don't know AD square. Then what is CD square? CD is 1, so it is equals to 1 square. AC is root 2, so it is root 2 square. Perfect. Okay, now we know square and square root cancel. It becomes 2. 1 square is 1 equals to AD square. What is happening here? Then see, AD square equals to 1 plus 2 is 3, right? Now we again take the square root. AD square equals to, its square root equals to root 3. So again the square root and square cancel, and we got AD equals to root 3. So this is how our construction that we have done is true. Okay, now we know this, and after this we had found out where, how much is the length, which is root 2, how much is the length, root 3, right? Which is the point. So root 2 is this blue point, right? And root 3 is this point, pink point. Okay, now how to estimate these values? See, root 2, when manual calculation was done, root 2 was 1.414 and root 3 was 1.732. Now how do we estimate these values? By looking at this number line. This is what we are going to see. Ready? Okay, so see, root 2 is here, over here, right? Where the red line is cutting. Okay, so now I just highlight it. Now see, this is 1, right? And after that 1, what are the numbers that are coming after 1? We know there is 1.1, 1.2, 1.3, 1.4. See, after 1.4 there is this red line, right? So that means this is 1.4 estimated till 1 decimal point, right? Now how to estimate root 3? Now again let us erase all of this and let us estimate root 3. Now how to estimate root 3? Again we know at this b there is 1, then there is 1.1, here it is 1.2, here it is 1.3, here it is 1.4, here it is 1.5, here it is 1.6, here it is 1.7. See, after 1.7 there is a little more, but we know at least 1.7 is there. So this is how we can estimate the value of root 3 by looking at the number line. We got this? Isn't it interesting? So without even calculation, we can have by construction the values of irrational numbers, right? Now I'm going to show you a very interesting thing. Look here. Amazing, right? What is all this? This is the spiral of Theodorus, also called Einstein's spiral or Pythagorean spiral. Can you guess why Pythagorean spiral? You guessed it right. Pythagoras theorem was used in it, right? So root 1, root 2, root 1 is equal to 1. So it's the same. Root 2, root 3, root 4. Do you think you can draw this Pythagorean spiral? Make sure you're doing it and trying it and let me know. Alright? Okay. So now today what have we covered? Today we have covered how can we plot or locate irrational numbers on the number line, right? How we can prove that our construction is right by using Pythagoras theorem, right? How to estimate the root values without calculation, right? And this beautiful, beautiful Pythagorean spiral, which you really should try. You know, it's a masterpiece. Okay, now this was about it, but what are, okay, I'll just show you on my screen. Do you think you will be able to locate root 7.5 on the number line? How can we do that? Well, try to find it out, because this is what we are going to discuss in our next session. So, let's meet in the next session. Till then, take care, keep practicing. Bye.